Hi, in this video we will see how powers of transition matrix naturally appear in the computations of Markov chain and what are the meanings of the components of these powers. Well, recall first that Markov chain is the version we are working is discrete, so it will have a sequence of state vectors, initial one x0, then the first one, second one, and so on. And we have a transition matrix P. This tells us state I, so where Pij says is equal to probability of state J evolves to state I in one step. So it's just one transition. What is the probability that state J evolves to state I? And what else we know? We know that every state vector can be determined by previous state vector. So this is how a state vector in the next step depends on the state vector at this stage. In other words, x1 is equal to p times initial state. Then x2 is equal to p x1. But if you look at this guy, x1 itself is px0. And this is p squared times x0. How about x3? Well, we have p times x2. And this is p. While x2 itself is p2 times x0. So p2 x0. And that gives us p3x0. And in general, you can see that xk plus 1 is equal to p to the power k plus 1 of x0. You see here, so x1 is p to the power 1 x0, x2 is p to the power 2 x0, x3 is p to the power 3 x0, and so on. And what does this say? It says that each entry of this guy has a very nice meaning. So p k, let me write this with k, this will make this better. pk, the ij entry of pk is the probability of moving from state j to state I in how many transition? In k transition. So it goes after k time evolution, you get from state j to state I. That's the portion or the probability of state j appeared in state I. So this is how powers of the transition matrix appear. Let's do some examples. I have one example actually, and that will show us a little bit more. So here we have P, which is the transition matrix, is 0.1, 0.6, 0.9, and 0.4. and x0 is 10 and 2. So here, then we can find x1. x1 is just p times x0. This is 0 0.1, 0 0.6, 0 0.9, 0 0.4 times x0, 10, 20. This is 1 plus 12. Yeah. And this guy is 9 plus 8. And this gives us 13. And 9 plus 8 is 17. One of the characteristics of the state vectors in the Markov chains is that the sum of the components of state vectors always stay the same. So the population, you don't have anyone leaving the process or anything leaving, just one transform to another one or the other way. Okay. x2 here would go as px1, and that is 0, 1, 0 0.6, 0 0.9, 0 0.4. And this is 13, 17. This is 1.3 and 7. This is 6, 10.2 plus. This is 9. So 9 and this is 117. But okay, I have one digit here. So it's 11.7 plus. And then 4 times that is 8. 4 and 68, and then I have 1 here. And when you add, you get 11.5, and this is 5, and then 6, 7, and there's 1, 8. As you can also do this in different forms. So P2 here is equal to, so this is 0 0.01 plus 0 0.54. This goes there, 0 0.06 plus 0 0.24. And this will go 0 0.09 plus 0 0.36. And this over there is 0. 0.54 plus 0 0.16. And if we do the addition here, this will be 0 0.55, and that is 0 0.45. This is 0 0.3, and this is 0 0.7. This is P2. And if you multiply P2 to x0, you will see that. So P2 to x0, which is 10, 20, will give us exactly the same number as we have here. Try that. You will see that that works the same. Part 2 says, what proportion of the state 1 population will be in the state 2 after 2 steps? What does this mean? It means that if I start with 1, 0, yes, all people are in state 1, and then I apply the let the Markov chain evolve the state vector twice. So it will be P, which is 0 0.1, 0 0.6, 0 0.9, 0 0.4. This will give us the first time. Then we do another time. And this is exactly what we have as P2, 0.55, 0.45, 0.3, 0.7. And then multiply 1, 0. This will give us 0.55 and 0.45. In other words, the proportion, the probability of state 1 going to state 1 in 2 transition, from 1 going to 1 is equal to 0.55. From state 1 going to state 2 in 2 transition is equal to, from 1 going to 2 is 0.45. And while the other components also you see that from state 2 to state 1 in 2 transition, this is 2 component of P2, which is 0.3, and from state 2 going to state 2 in 2 transition is equal to 0.7. So the powers of the transition matrix and their meaning are important when we study Markov chain.